Hey guys, so after all of our hard work solving those systems of equations, I'm going to show you how to do it on your calculator. Sorry, but you need to make sure that you don't rely on this because on your test, there's going to be two sections. There's going to be a calculator and a non-calculator section. So don't just rely on what I'm going to show you here today, okay? All right, so we're going to be learning about how to solve systems of equations using matrices. So a matrix is how your calculator kind of perceives these systems of equations. So we kind of have to learn the calculator's language. We have to learn how to plug it in to our calculator. So let's do that together here. So first off, let's take a look at how we can write a matrix. So do you see how we have like x, 2x, 3, 1y, 1x, negative 1, and 2? Well, this is the matrix for that. Now, notice some important things. We have an x column, we have a y column, we have a number column. Okay, and then also notice that there's no x's, no y's, no commas, no decimals, anything like that. So we just go 1 and 2, because those are what my x's are, 3 and 1, because that's what my y's are, and negative 1 and 2, because that's what my whole numbers are. This is a 2 by 3 matrix, okay? Over here, we have a 3 by 4, okay? So instead of just being x and y, this one has x, y, and z, all right? So you can see this one, x, y, z, whole number, okay? But you can see how it lines up. My x's are 1, 2, 1, 3, 1, 1, 2, negative 1, 1. My whole numbers are 1, 2, 2. So hopefully you can see that relationship. All right, now let's come down here. And so once again, this is what's known as a solution matrix. We'll be talking more about that in a little bit. But this is what's also known as reduced row echelon form. So you see how this has like a 1, 0 answer, 0, 1 answer? I'll be showing you how to find those answers here whenever we solve. But this dimension is going to be a 2 by 3 answer, meaning we're going to get an answer for x and an answer for y. And this one's going to be a 3 by 4. All right, so we're going to go ahead and write some matrices, but a quick warning, all right? Watch the order of the variables. They must be in the same column. In other words, you have to put everything in the correct order to get it to work right, all right? If a value is missing, just put a 0 there. So like if you don't have an x, just put a 0 there. If you don't have a number on the other side, just put a 0 there, okay? All right. And then if you have a number that's being subtracted like this 7, it's a minus 7, it's a negative. So whenever you put it into your calculator and put it in as a matrix, make sure you put it in as negative 7, okay? Remember, no commas. So let's write the matrix for this one. Now, before I write the matrix for this one, we have something important to do. Do you see how this y, this 5y, and this 4x, they're in the wrong order? Remember, whenever we write a matrix, we're going to go x column, y column, whole numbers. So the first thing I need to do here is switch those two. All right, so I'm going to rewrite it over here. It could be negative 4x plus 5y equals negative 7. Now, do you see how the negative, that minus, went with the 4x, and the 5 was positive, so it's plus. So I switch those around like that. My other equation doesn't need to change. It's still just going to be 3x minus 7y equals 15. So then I can write my matrix for this, okay? So remember, we're going to have an x column, a y column, and a whole number column, right? So my x column is going to be negative 4, 3. My y column is going to be 5, negative 7. And then my whole number column is going to be negative 7, 15. And this is a 2 by 3 matrix, okay? All right, so that's how you can write out your matrix. Let's write this one out. All right, hold on though. Before we write out, we've got to make sure everything's in the right order. And you can see here that this negative 12 and that 7z, they're switched, right? Now this one's a little bit trickier because they're on opposite sides of the equal sign. So what I'm going to do here is I need to minus the 7z and add the 12. So it's going to end up looking like this. X plus 8y minus 7z equals positive 12. All right, and then look at the second one. Do I need to shift that one around at all? I don't think so. Everything's right over. We got x, y, z, equal sign, whole number. Everything's perfect. So I'm just going to rewrite this. 5x plus 9y plus 5z equals 15. All right, let's take a look at our last one. Oh, our last one, I need to switch this one around too. That x and that z, they're flipped. I need to put them back in the right order. Now, make sure you bring the negatives with it. And then this one, we're not moving it to the other side of the equal sign, so nothing's really going to change here. All right, so it's going to be negative 8x minus 3y plus 6z equals 1. Okay? All right, so let's write our matrix for this. So this one's going to be pretty big. And for this one, I'm going to have an x column, a y column, a z column, and a whole number column. Okay? So we got all three there. So let's see, my x's are going to be 1, 5, and negative 8. My y's are going to be 8, 9, and negative 3. My z's are going to be negative 7, 5, and 6. And my whole numbers are going to be 12, 15, and 1. Okay? So, hopefully that makes sense to you there. All right, how my different ones come together. Okay? All right, so there's that one. Now, let's turn the page, and, oh, real quick, this one is a 3 by 4. So, let's actually solve one of these guys. Okay, well actually let's write the system of equations from the starting point here. So let's say I have this system of equations. 5, 1, negative 3, negative 2, 2, 4. What does this mean? Well, remember this is our x, this is our y, this is our whole number. So it's going to be 5x plus y equals negative 3, and negative 2x plus 2y equals 4. So there's my equation. For this one is a solution matrix. You know it's a solution matrix because we have those ones and zeros. So listen, this is what we're going to do in a second. We're going to plug this matrix into our calculator like this, and your calculator is going to spit out something like this because this is how the calculator communicates. So if my calculator spit out something like that, how would I know what the answer is? Well, it's actually telling me. Look at this. Here's my x's, here's my y's, here's my whole numbers, right? Well, look. If I have 1x and 0 y's, 1x equals 4. Oh, it just told me the answer. You see what I'm saying? That's why it's called a solution matrix. Same thing here. 0 x's and 1 y equals negative 6. So just like that, bam, we got our answers. Okay? So that's how we read a solution matrix. All right. Let's take a look now at if it's a 3 by 4. So this is a 3 by 4. So this is a system of 3 equations. So once again, this one has an x, a y, z, and a whole number. So x, y, z, whole number. So this one, 0 x's, 1 y plus 2, oops, let's make that a little bit better, plus 2z equals 4. So 1y plus 2z equals 4. That's my first equation. My next one's going to be negative 2x plus 3y minus 6z equals 9. And then my last equation will be 1x plus 1z, no y on this one, equals 3. Okay? All right. So now on this one here, this is another solution matrix. You can see all the ones and zeros. Okay? And nothing else except for our numbers. So remember, this is our x, this is our y, this is our z, this is our whole number. So like, if I plugged this in, it might spit out something like this. Where I have 1x equals negative 5, 1y equals 8, and 1z equals 2. All right, so it spits it out nice and pretty for us. Okay, so what about if there's no solution or infinitely many solutions? Okay, I want you to look at this one. This one, we can see what happens here, right? Okay, look. This one on the left, that A right there, x, y, z, right? So x equals 5, or x, y whole number, I should say. Y equals 2. So this one has one solution, okay? So this one is one solution. And nothing else, just one solution, all right? But look at this one. This is where it gets weird, okay? This one we have x equals 5 and 0 equals 2, right? No x, no y, we just get 0 equals 2. Do y'all remember what happens whenever we have just no x or y, we just have a number equals a number? It's either going to be no solution or infinitely many. How do we tell which one it is? This one, you see how 0 doesn't equal 2. That is not true. So this one's going to be no solution. Okay? But what about this one? This one I have x equals 5 and 0 equals 0. Oh, well this one, x and y's went away, but that time it's actually true. 0 does equal 0. So this one's going to be infinitely many solutions. All right, so that's the difference there. We can do the same thing with our 3x4s, right? This one we can tell. Do you see how it has 3 1s? And so it's actually going to be true. So this one's going to be one solution. And we can actually honestly just look at the last row, the bottom row. And you see how on this bottom row we just have 0 equals 3, right? That one, of course, is no solution. And then, look here. If I have 0 equals 0, that is infinitely many solutions. All right? So, now that we know how to read our answers, let's actually use our calculator to find one. So if you turn the page with me here, you will see all of these instructions. You can pause to read, but we're going to go through it together. All right? So first we're going to write our matrix, we're going to plug it in, we're going to get a solution matrix, and then that's going to tell us what our answer is. Okay? So this one here is a 3x4. We're going to have some 3x4s, we're going to have some 2x3s. We're going to start off with a couple 3x4s, and then on the next page, we're going to have a 2x3. Okay? All right, so let's come down here, and we have our 3x4 here. We have 3x plus 2y minus z equals 11, 2x minus y plus 2z equals negative 3, and x plus 3y minus z equals 8. Okay? All right, so here we go. Let's run our matrix. Do I need to reorder any of these? No, it's already in the right order. That's good. So we're going to have 3, 2, negative 1, 11, 2, negative 1, 2, negative 3, and 1, 3, negative 1, 8. Okay? So there is our, oh shoot, Mr. Martin, you silly goose. I wrote that in the solution matrix section. We need to write it in the matrix section. All right, so I'm going to write it over here instead. My bad, guys. So 3, 2, negative 1, 11, 2, negative 1, 2, negative 3, 1, 3, negative 1, 8. Okay, so now we need to plug it into one of our calculators. Now, let me show you how to do that here real quick. Okay. So to do this, I'm going to pull up my calculator, all right, and so here's mine. Here's what we do. Here's the steps. Step number 1, go to matrix. So you can see matrix in blue right there. Go second matrix, and it'll pull up this screen, okay? Now, we're going to go over twice to edit, and we're going to edit matrix A. So go over twice to edit, and then hit enter. Now, this is where we decide, is it a 2x3 matrix or is it a 3x4 matrix? So if we look back here, it is a 3x4 matrix. It's big. So we're going to go 3, enter, 4, enter, and it's going to give me the grid to plug in my answers here. Okay? So we had 3, 2, negative 1, 11. So let's put those in here. 3, 2, negative 1, 11, and then I had 2, negative 1, 2, negative 3, so 2, negative 1, 2, negative 3. As you're putting these in here, make sure that you use negatives and not minus. So make sure you're using that negative button. Okay, next up we're going to do 1, 3, negative 1, 8. So 1, enter, 3, enter, negative 1, enter, 8, enter. Okay, once you get to this point, this step is really, really important because everybody messes up on this one, okay? We can't just start running our program yet. What we have to do is we have to exit out of our matrix. And to exit out of our matrix, we have to go second, quit. Okay, so quit, you can see it's right above the mode button right there. I can go second, quit, and it's going to take me back to the starting page. And then we're going to tell our matrix, our calculator, what program to run with this matrix, and then we're going to tell it which matrix to use. So we still have two big important steps here. So we're going to go second matrix, and you can see now, do you see how it's, you can see there's a 3 by 4 matrix in matrix A. We used it, okay? So then we're going to go over 1 to math, and then I want you to go up 1, 2, 3, 4, 5 to letter B. Reduced row echelon form, RREF, okay? Don't use just ref, RREF, okay? It's a special ref. All right, so we're going to hit enter, okay? RREF, and then you see we're telling our calculator run this program, but then the calculator is asking, well, what matrix should I use for this program? So we're going to go back into matrix, second matrix, and we're going to click enter on A because that's the one we changed. So we're going to click enter on A, and now we're telling our calculator run reduced row echelon form for matrix A. Then if we hit enter, it's going to give us an answer. So here is our solution matrix, 1, 0, 0, 2. So here's our solution matrix, 1, 0, 0, 2. Spread those out a little bit. 1, 0, 0, 2, 0, 1, 0, 1, and 0, 0, 1, negative 3. Okay? So remember what this means. This is my x, this is my y, this is my z, this is my whole number. Okay? So that means here that my x equals 2, my y equals 1, and my z equals negative 3. All right, so there are our answers. To write our solution, this is where we go parentheses, x, comma, y, comma, z. All right, so my solution is going to look like this. It's going to be 2, comma, 1, comma, negative 3. You could also just write your solution like this. Either one is correct and either one is fine. Okay? All right, let's take a look at number 5. So number 5 is our first word problem, and we're trying to figure out how many nickels, dimes, and quarters do we have. All right, so we have 85 coins in nickels, dimes, and quarters. So I'm going to write this. I'm going to go nickels plus dimes plus quarters equals 85. All right, then it says with a combined value of $13.25. So that's going to be 5 cents for each nickel plus 10 cents for each dime plus 25 cents for each quarter equals $13.25. Okay? All right, then there says there are twice as many quarters as dimes. Find the number of each type of coin. So twice as many quarters as dimes. So there's tons of quarters. We need to multiply the dimes by 2 to equal the quarters. So we're going to go quarters equals 2D. Okay, so now, I have my 3 equations, and we need to make a matrix out of those 3 equations, but we have a problem. Do you see how this third equation is written out of order, right? So this is my system of equations, but this third one is written out of order. So we want to change that to be written in order. So we need to move my dimes over to the left side, and we'll have 0 nickels, negative 2 dimes, 1 quarter, and 0 whole numbers. So it's going to look like this. If I minus 2d to both sides, my equation instead is going to look like negative 2d plus Q equals 0. Okay? So we can kind of ignore that right now, and here are my three equations. So let's write our matrix. And in my matrix, we're going to have my N column, my D column, my Q column, and my whole number column, right? Okay, so my nickel columns, we're going to have 1 for this one, 0.05 for this one, and you see in this third equation, I have 0 nickels, so 0. All right, then for my D column, I'm going to have 1, 0.10, and -2. For my Q column, I'm going to have 1, 0.25, and 1. And then for my whole number, I'm going to have 85, 13.25, and 0. Okay? Then I can plug this in and I can get my answer. Okay? All right, so let's plug this into our calculator and let's get our answer here. Okay? So to get my answer, we're going to go to matrix. We're going to go over twice to edit. And we already have a matrix in there, and it's already a 3 by 4, so there's not a whole lot I need to change. Okay? So we just need to fix these numbers. All right, so instead of having a 3 here, we're going to have 1, 1, 1, 85. So 1 enter, 1 enter, 1 enter, 85 enter. So it just covers up what was already there. So not as much to worry about. All right, then I'm going to have 0.05, 0.10, 0.25. So 0.05, 0.10, and 0.25 is $13.25, so 13.25. And then we're going to have 0, -2, 1, 0. So 0 enter, -2 enter, 1 enter, 0 enter. Okay? All right, so do you remember what comes next after this step? It's important. We go second, quit. Takes us out of it. Because if we start trying to run the program while we're still inside of editing the matrix, it's going to make everything wrong. Okay? So we're going to go second, quit. Then we're going to go second, matrix, over 1 to math, up 1, 2, 3, 4 to 1, 2, 3, 4, 5 to reduced row echelon form. Okay? Hit enter on reduced row echelon form, and then go back to matrix and tell it, yeah, we want to use matrix A again this time, and we'll get another answer. So look at this. Remember what these represent, okay? Remember that this represents your X, your Y, and your Z, or in other words, it represents your N, your D, and your Q, right? And then this is still our whole number. So it means 1 nickel, we have 25 nickels, 20 dimes, and then 40 quarters, okay? So look at this. So 25 nickels, then we have 20 dimes, and 40 quarters, okay? Okay, so our last question is here. How much total money do you have in just nickels and dimes? Okay? How much total money do you have in just nickels and dimes? Well, that's going to be 0.05 times 25 plus 0.10 times 20, right? If I'm just doing those two. So let's see here. 0.05 times 25 plus 0.10 times 20, which is, so if we were just looking at nickels and dimes, we would just have $3.25.